Hi everyone, and welcome to our video on solving a right triangle where we have two sides known and only one angle. So it says solve the right triangle where angle C is the right angle, little a is 7, little b is 4. We'll write our answer as exact values and as decimal approximations. All right, so when it says solve the right triangle, first thing, I'm just going to sketch it out. Now a sketch might not be needed in some of these problems like this, but I think it's always a good idea. Okay, so I'm going to say there's my right triangle. They said angle C is the right angle. So here's angle C, which means the hypotenuse is little c. And then they say little a and little b are 7 and 4. So it doesn't really matter, it looks like, how I labeled this because they're unknown anyway. So I'm going to say there's angle A and there's angle B. And so little a is right here, that's 7. And then little b is directly opposite of capital B, and that's 4. Okay, so we have our setup here. And then with this setup, I like to do our kind of like answers. There's our angles, and then here's our sides. And I'm going to fill in what we have. So we know angle C is 90, and then little b is 4, and little a is 7. Okay, so there's our answer box. All right, so now that we've got this, well, because I have two sides, I could do Pythagorean's theorem to get the missing side. So that's what I'm going to do first. So let's find missing side. Okay, so that's Pythagorean's theorem. Based on this triangle, so we could do A, B, and C. I'm going to do opposite squared plus adjacent squared equals the hypotenuse squared, though, because I want to label those here anyway. Okay, so it just depends on where my angle is. Let's focus on angle A as my main angle. So if angle A is my focus, then that means little a is opposite, little b is the adjacent, and then capital or little c is the hypotenuse. Okay, so that would be the hypotenuse no matter what. And then that way now I can plug those in. I think this helps with making sure we put the numbers in the right spot. So our opposite is 7 getting squared. Our adjacent is 4 getting squared. And then our hypotenuse is what we're trying to find. That will be little c. Okay, I kept it as hypotenuse. And then here we'll just do our squaring. So 7 squared is 49. 4 squared is 16. Let's change that to be c squared now. 49 plus 16 is 65. And then we'll square root both sides. Again, for good habit, we should put plus minus. However, in this case, we're going to say it should be positive because we have a right triangle. Triangle sides should be positive. Okay, and then the square root of 65 doesn't reduce at all because its prime factors are 13 and 5 only. So that means we have square root of 65 is just c. Okay, because it's 13 and 5, so those don't break down any further. That's as good as it gets. Okay, so our c is the square root of 65. And I'm putting it there. Okay, so it said write your answer as an exact value and a decimal approximation. So I'm going to do the equivalently. So square root of 65. So I have the calculator open. Square root 65, 8.06. Okay, so there they are. Okay, so the exact value is the square root. The approximation is the decimal. Okay, our second step to this problem, and maybe we could have done it first. Let's get the angles. To find the angles, that's where we can use SOHCAHTOA. All right, so using our SOHCAHTOA, and again, angle A is how I have the triangle matched with my opposite, adjacent, and hypotenuse. So I'm going to set each of these up. So I have sine of angle A. That's what I need to find. Sine of angle A is equal to the opposite, which is 7, over the hypotenuse, which we have is square root of 65. Okay, so that's how we can find angle A. The cosine, let's set that one up. Let's get these set up first. The other way to find angle A is, we could have done cosine of angle A equals the adjacent, which is 4 over the hypotenuse, which is square root of 65. Or we could have found angle A. So notice all of these are finding angle A. Tangent of A is equal to opposite 7 over adjacent 4. Okay, well, this is where we need to figure out, well, how do these help me find the angle A? To find them, we need to use our inverse trig property. Okay, so if I take the inverse, let's rewrite it down below. I need a little bit more space, so I'm gonna put a little space here. Don't write anything yet. I'm gonna put this in blue. We would need to do the sine inverse of both sides, like that. There we go, just like that. And that should give us angle A. So the sine inverse and sine would cancel, and we're left with just A on the left. And then this on the right is something we could plug into a calculator. Okay, so that would be the exact value of it though. So I'm gonna underline that and put a star. That would be the exact value. Okay, so that would be the exact value of angle A. All right, however, they can look a little weird. Let's do it with the tangent as well. So we could do the cosine, but let's just do the tangent of it also. So it's kind of like the sine. I'm going to say let's leave a little space, and in blue, do the tangent inverse of both sides. So I'm just doing the inverse trig function of whatever I currently have. Tangent inverse, and then the tangent inverse, so I put that in on the left of, oops, there we go, 7/4. Okay, so again, the A would be the only thing left over, and tangent inverse of 7/4 is on the right. Okay, so all I did, so it's to show two different things. So this is also the exact value answer for A. Okay, however, what it did is I'm just showing you could solve it in different ways. So these should be the same. Let's find out. Okay, so let's go to Desmos. Now, it probably wants it in degrees, especially since we have triangles. Usually they want degrees. Now, you could always change it to radians. Okay, let's leave it in degrees. Okay, so sine inverse is in our function menu, sine inverse, and then, what was it, 7 over the square root of 65? Is that right? Let me double check. Yeah, 7 over the square root of 65, and it gives us that angle, 60.26 to 2 decimals. Okay, now let's see if it gives us the same thing with the tangent. So it was 7 divided by 4. Yeah, look at that, same thing. Okay, so again, just showing we could find the missing angle using different methods. Either way, we had to use an inverse, but still, we found it. Okay, so we have both of those. So I started, but in my answer box, let's just do the decimal. So 60.26. That was angle A. Okay, and then angle B, I can do another SOHCAHTOA if I wanted to with angle B as the focus. So if I did, so I'm not gonna go because we could do it quicker. I'm just gonna mark it in green. So if I said, oh, I'd rather look at angle B and do SOHCAHTOA. So I'm not gonna do too much more than just mark this. If I were to focus on angle B, that makes this the opposite. That makes 7 the adjacent. C would still be the hypotenuse. Okay, so notice whichever angle we choose will determine where the opposite and adjacent go. Okay, so I could find angle B using SOHCAHTOA. However, because I already have 2 angles, I know that all 3 need to add up to 180. I can find B using that. Okay, so let's just go to the calculator. Or we could do the complement. So if I already have 190 degree, this B would be the complement of 60.26, which means all I have to do is subtract 90. There we go. 29.74 degrees would be that answer. Okay, so that's a little faster than doing SOHCAHTOA all the way. Done. There they all are. Okay, so that's how we can find all of the parts of a triangle. That's also how we can find an angle. So we have to use inverse trig to find angles on some of these problems. Okay, that's that. Thank you for watching. If you have questions, please let me know.